that Perl module, I had to develop 2 other Perl modules. For example, I needed a way to pass file descriptors to unrelated processes. That became IOFD pass, a very tiny module with, I think, only a single function, or maybe 2 functions. And another module called proc spawn, which basically does fork and exec on the C level, where it's safe. And with that, I wrote AnyEvent fork. And AnyEvent fork basically does that. Instead of forking and using the child process directly, it forks and execs a new Perl interpreter, prepares it in the way you want, and then gives you a socket connection to it so you can play with it. So, how does it work? The usage is basically, here's an example. You create a new AnyEvent fork object, and an AnyEvent fork object is kind of a process. It's not your child process, but it's some process that is yours. And then you can call various methods on it. For example, require. Require will simply require the module you give it in the child process. And another important method is run. That's the last method you can run, execute in the fork object. And there, oh god, there's a bug. Of course, the string should end here. It basically, in the child, just calls this function and passes it a Unix domain socket. And it also wants a callback, this one, and this callback is called in the parent, and it gets the other side of this Unix domain socket. So basically, this master file handle is connected to this child process. You can throw it away. You don't have to use it. You can use it for all kinds of purposes. You can communicate with your child process with it, but you don't have to. And this module is actually quite small, and the reason is because for some reason I don't understand, I wrote 4 modules which all build on this and all do a tiny little thing. And maybe I should have put all of them in one module. But anyways, it's too late for that. So let me make a few other examples and explain what happens. Ah, yeah, right. This is actually the full example. So this is the parent process, and this is this my module thing. And the reason why this is in a separate file is because this AnyEvent fork gives me a new empty Perl processes with almost nothing loaded. And specifically, since it's not a copy of my process, unfortunately, it doesn't have the code of my process loaded. So I need to load some code from disk first and compile it. And this is an example function. So this is the worker function that is called. And as the first argument, it gets the slave file handle. And then these are the ones that are connected. I have lots of other functions which might be interesting. Here's an example, a hypothetical problem. You have something like Apache, the old Apache, where you have one master process and lots of child processes who are the actual workers. So you want to have a process pool, a worker process pool that does something for you. And here's a new thing. So the first thing is, since imagine it's Apache, I create my port 80 listener socket, for example. And then I create a new process with AnyEvent fork and load some stuff, for example, my server, which presumably is my worker code. And then I actually send it the listening socket. So this passes the file handle to this new process. I can't pass it really in any other way, because the process is not really a fork child process. So just as I have to load the modules, I also have to send the file handle separately. And now comes a new trick. I don't want just one process, I want many of them. So there's another method, fork. So my new process, I store in a variable called pool, and then I have a loop that 10 times calls fork, And fork, as you can guess, forks this process, sends it some stuff, and then runs the my server run function that does whatever you want. So, why would you do that? Because when you start a new Perl interpreter and you require this stuff, it first needs to compile your modules, which of course is not free, it's not instant, it takes a while. Probably Perl is very fast, but still it's CPU time. And the second thing is, if you create 20 processes or 10 processes with this way, then they don't share memory, because each time Perl loads the module, each Perl process allocates separate memory. It will end up with identical contents, but of course the kernel doesn't know that, so it's separate memory. And with this method, I actually create some kind of master process, a template, a process that is then copied. So why is fork safe here and not when I do it directly? Why it isn't? The thing is, imagine this is in a module or something. In a module, you don't know what the user who calls your code actually does before he calls your code. Or in other words, we all know when we publish a module, users might use them in interesting and very stupid ways, for example. Maybe it's not even stupid, maybe it just doesn't work for you. It's something that you didn't expect. And since you create here a process from scratch, it will only contain exactly the code that you load into it. So when you load glib, but you don't open Windows, then you know it's safe to fork, because GTK or glib will not have an open connection to the X server, for example. If you just fork your current process, you don't know whether the user has opened X Windows before or not in the process, but in this process you know because it's new, and you're the only one who can make it compile stuff. So this creates a process pool. And always, if you have a question, or more likely, if this is not actually something you need every day, then feel free to ignore me. I'm not pleased to sorry if you ignore me, because I feel that this is a very specific and thing that is not really something that everybody needs every day. Yeah, this is, for example, the worker code in this case. This case doesn't actually use the socket that is passed to it, so it closes it just so that there's one file descriptor less, a bit less memory in the kernel, and then here it has some kind of accept and do something loop that then implements your HTTP server or whatever. And the thing is that if you look at the starting program, what it does here is sends something to the child. Here it sends the listener socket to the child process, and here it sends something else, namely the ID, just some sequence number really for the socket. And the thing is that everything that you send to some object will eventually be passed to the worker function. So the worker function is first thing gets the socket that they always get, then the listener socket that we send with sendfh, and lastly the ID that was sent as the last thing. So this is a worker pool, but you can also use it for other things. I told you that forking is slow. It can take really surprising amounts of time, and even if it doesn't take so long, sometimes you do it very often, and then again it adds up. So you can use AnyEvent fork as a fast way of starting processes, which initially I didn't think would be the case. I thought initially, okay, I fork a big process in Linux, okay, it's slow, but the alternative is I create a new process, compile some stuff, and then pass some file descriptors between the processes, and I do that from Perl. That surely must be slower, but if you have like 5 or 10 megabyte process, then it turns out it's actually faster than doing the fork, because again, fork is really surprisingly slow. it's surprisingly slow because it surprised me. So here's an example of how to do that. Again, AnyEvent fork new creates a new fork process, and then we call another method eval, and eval does what you probably would expect. It just takes some Perl source code and evaluates it. And in this case, I do not have my code in a separate file. I have the code as a string inline. So this is the worker code basically. And then I send it the output file handle, which is where I want to have the output. I send it some arguments, bin echo hi, and I run it, use a condition variable, great, and receive standard error of the program as the result of the run callback. So the helper function gets the file handle that it always gets, the file handle that is also passed later, the other side of which is passed to this. The output file handle that I gave it, and the command echo hi that is also passed. Probably clear, close, and exec. Okay, forget this detail. So anyways, I redirect standard out to the output file handle. Ah, right, okay. This file handle will have the close and exec flag set, but if you redirect standard out to this file descriptor, then Perl will clear it. So this $output will be closed, and standard out will of course not be closed when you exec later. And standard error I redirect to the socket I get, and then I just exec the command. So this is why I get standard error as a result from this callback, because I use the Unix domain socket pass to it as standard error. So this is probably the weirdest, the most complicated way to execute an external program that I've written. And of course I wouldn't do this normally, but sometimes when I know fork is a bit slow, or I need to run a lot of programs for my Perl daemon, then I would probably go this route. You know, it's important that it exists for ease of mind. I could do it properly if I wanted. Then there are other tricks. For example, what bothers me a lot is that I have to put my worker code into an extra file so the child process can read it. I'm sure most of you don't give a fuck because you all do nice object-oriented programming and you always have a separate PM file for your worker code anyways. But sometimes I like to write standalone programs and then having standalone programs which require extra files. Well, you wouldn't have a demo with external files, right? So it's one exe file, finish. So, of course, you can have a data section, read it, evaluate it, run it, finished. And there's another way to do it. Ah, right, okay. So, there are some problems. I thought of everything really. Imagine you create a program with, for example, PAR, the Perl Archive Packer Standalone. I don't even know what it stands for. Anybody knows what PAR stands for? The PAR module? Perl Archive, right. So the thing is, you can create basically on Windows, for example, a single exe file which contains your program and all your modules. The problem is you cannot fork and exec a Perl interpreter when you are in a PAR program, because you might not have a Perl interpreter on the system installed. Because your exe file is not really a Perl interpreter, it's a Perl interpreter which is hardwired to call your program. So what do you do in that case? So there is, of course, a solution for that. AnyEvent fork normally creates one single Perl process. And every time we call new, it will actually fork this prototype process. And there is a way to get this prototype process without exec. And this is AnyEvent fork early. It's called early because you need to put it very early into your main program. Basically, when you put it as the first thing in your main program, and this comment up there is supposed to indicate this is a program, not a module. When you put it as the very first thing, then you can fork safely because nothing dangerous has happened yet. Nobody has created threads yet. Nobody has opened X windows or anything. So this forks early. And then there's a second module, very hacky. It's called AnyEvent fork template. And the purpose of that is, well, you put all your worker code in the beginning of your file, and then use AnyEvent fork template, and then you will have a variable called $template, which is an AnyEvent fork process, which is a copy of all that. So you can actually have a single file with worker and the main program without actually relying on an external Perl interpreter that you can start. The rest is probably uninteresting. Yeah, there's stuff in there. This is not the only module though, because if you were actually able to follow all that in the beginning, I told you you have a new process and you have a socket in the parent, the Unix domain socket, and the other end of that socket is connected to your child. But then that's all you get. If you want to talk to the child, well, it's your problem. And unfortunately, it's also my problem. So I thought, why not solve it in a simple way or something that is useful for me. So this solution is AnyEvent fork RPC. And the RPC, of course, stands for remote procedure call. So how it works, basically you create an AnyEvent fork process, object, load some code, anything you do normally, and instead of calling the normal run method, you call the AnyEvent fork RPC run method with this very funny syntax, which I never see in practice, but it's really funny, right? I mean, calling a functional method. Anyways, you can basically, this is nothing else than instead of calling the normal run method, you call another method in another module. And that also wants the function name that it calls. The difference is that it doesn't want a call, it doesn't accept a callback, but instead it returns an RPC object, or rather a code reference really, because it's really very simple. So the code reference allows you to do this, you can call it, obviously it's a code reference, with some stuff, and the callback. And what it does is, it takes this some stuff, transfers it magically over the Unix domain socket to your process, to your subprocess, calls the function here with it, and whatever this function returns will eventually be passed to this callback. So basically you have a code reference, and then you can call it like 100 times with some jobs. Your child process will, which is not a real child process, your subprocess will execute all your jobs, and eventually you will be called back with the results. And this is probably not a solution for everyone, and you can't extend it because it's a code reference, so there's no way to kind of improve it later with method calls, which is maybe a bad design. But if you just want to do heavy lifting, heavy CPU intensive work in a subprocess, then it's really hard to make it any shorter than this. Most modules who manage to make it any shorter use fork, so they're doomed. But AnyEvent fork RPC is also not the last module, because this gives you only one process. And what we really do is like a pool of processes. We want dozens of processes who all hammer my CPU or whatever. And of course there's a module for that too. Ah, wait, I'm not finished. There are various backends of AnyEvent fork RPC. So the simplest backend is called the synchronous backend. And it's called synchronous because in the child, I call the subprocess, I always call child process, but they are not child process. Keep that in mind. I will not mention it again. So what it does is, it calls a function in the child process, and whatever it returns, it passes back. Or in other words, your child process will do exactly this single job in all your jobs in series. It can't run jobs in parallel because it just calls a function and waits until it returns. That's the synchronous backend. And what you can also see is that you can have various configuration stuff. For example, on error should be self-explaining. On event I will not explain. And on destroy is a code reference that's called when all the jobs are finished. Because when you want to exit your program, maybe you want to wait until all the jobs are actually done. And then you can use this for that. And the rest is really an example. For example, RPC RMDIA. So this is basically kind of like hack that gives you asynchronous I/O because you do the actual directory deleting in another process. So when it's very slow, I don't know if you ever bothered about the speed of RMDIA. I bother a lot about that. For me, it's important that while it hangs for an hour for the NFS server to come back, my program will still continue to run. And this is the synchronous backend. Obviously, there must be an asynchronous backend too. Let's skip the worker here. Oh, I didn't make a full example, that's so evil. Anyways, there's also the asynchronous backend, and you get it by specifying async1 when you create this thing. And the difference is that instead, your worker function that will execute the job gets an additional argument in the beginning. Here it's called done, and this is a code reference. And here what happens is that it will not wait for this function to return. Instead, you have to call the done callback when you have the job finished with whatever arguments you want the parent to receive. And this is asynchronous because as soon as this run function itself returns, the job might not be finished because nobody might have called done, but it will immediately be called with the next jobs. So, this uses AnyEvent, obviously. No, does it? Yeah, it does. So you could, for example, have a sub-process that does a lot of HTTP requests with AnyEvent HTTP, for example, and you can just queue job after job after job, and in Agile it would just queue it into AnyEvent HTTP, and they can actually be done in any order. So if one HTTP request is finished before the other, your parent callback, the callback in the parent process will be called with the results. That's why it's called asynchronous, because they can run in any order. But this is basically what you can say about this, this module. Here's another example which uses data for the actual worker code. And what does it do? Well, it's a counting job. Computers count a lot. And this is just there to illustrate that in the child you can use AnyEvent without bad conscience. So this is something that you call with count, and this then has a timer, and eventually when it's done with the counting, it will call the done callback, and the parent process calls it with creates 3 jobs, 3 seconds, 2 seconds, and 1 second of counting. And the order, I think I have the output here, is that the run function will be called with 3 to 1 in the same order as I submitted the jobs. Then it counts, but the finish callback in the parent will be called in the job 1 is not the first job, it's the job with the 1 second counter. So this is job 1, job 2, job 3. So this finishes first, even though it was started last. Okay, that's pretty basic. You did with Coro too, right? So since we, of course, want pools, we have a solution for that too. It's called AnyEvent Flood Pool, and that one has a shitload of configuration options. And I don't think I ever used it. Basically, it sits on top of AnyEvent fork RPC, so it gives you easy, simple RPC into a pool, and it has some management stuff. For example, you can say how many processes to start, maximum, how many processes you want to have idling around at all times, kind of pre-fork, and various things that decide when to start new jobs. So when you submit 100 jobs, these magic constants will somehow decide how many actual processes are supposed to execute these 100 jobs. Yeah, and something I forgot about the AnyEvent fork RPC is how do you pass things to another process, where to serialize them and deserialize them. And of course, until recently, you really had only the choice between slow, that was storable, but good, and fast, but bad, anything else really. For example, the default serializer is, I think, the string serializer, and this one just concatenate, this just allows you to pass strings to your subprocess, really just strings. But you can define your own serializer, or you can use a predefined storable serializer. And I just said there's the perfect solution for that, and that is CBOR XS. CBOR, there's also a JSON serializer, for example, but CBOR XS didn't exist when this stuff was written. So CBOR, can you just erase your brain, completely different topic? Didn't you always want to have a binary JSON format? Something that's like JSON but binary. Okay, I want it. Anyways, there's a shitload of formats. There's message pack, there's BSON, there is...
There's also serial.
I don't think that serial is supposed to be JSON replacement though. It's just another serializer. No, I didn't really look at it. It's not invented here, so... Anyway, so recently there was an RFC, like last year, about a new format called concise binary object representation. And this is basically JSON in binary, like to 99%. While everything else, like message pack and stuff, is JSON in binary to like 80 or 90% only. So everything you really want to pass into JSON, you can also do with CBOR, and it's fucking fast. But of course it has similar limitations like JSON. You can't by default serialize objects or something like that. It's not a Perl object serializer, it's a serializer for data, just like JSON is. And that should have been the default serializer, but then that would have been a big dependency, because AnyEvent fork is, well, it's pure Perl, but it already has dependencies. Never mind. So you can choose different serializers, and this thing then actually manages not one process, but multiple processes that then can execute your jobs. And now comes the best part. What else could there be? We have processes, we have RPC, we have pools of processes. Well, we don't have remote processes yet. And this is uses a trick that I often explain. It's not finished, it's a beta release, it says. Sometimes you want to run a process on another machine. Well, we always do, right? And some people use HTTP requests or something like that. And normal people use SSH, you know. So the thing is, okay, we can run other processes easily with SSH, but then they are not really the process you want. What you really want is Perl. And this module is a bit like AnyEvent fork, except it allows you to start the process yourself. For example, with SSH. And one method is the new execp method, which works like the execp function. That's why there's SSH twice. You know, this is the path, and this is the program name, and this is the first argument. And all you have to do is, no matter what you do here, the end result is Perl must run with standard input and standard output connected to Perl. doesn't need any parameters or anything. Just make sure, however you want to do it, Perl is running on the other side of standard input and standard output. And one way to do that is SSH. However, I found out that the Nagel algorithm and delayed acknowledgements can sometimes lead to SSH being a very, very bad protocol for RPC, because basically you send a request, SSH hands it to the kernel, and the kernel then waits, like 0.4 of a second or 0.04 of a second or something. It can take really long. So sometimes you can also do other stuff. For example, in one case, I just put Perl in inetd on another computer, behind a firewall, of course. So basically, each time I would tell it to that port, I would just get Perl, which doesn't print any prompt or anything, just Perl. So how you start Perl on another machine doesn't matter, as long as it's connected to standard in and standard out. And then the syntax is very similar to AnyEvent fork. You can require some code, you can evaluate code, you can run. And the difference is that AnyEvent fork hands one socket to the new process, and this one doesn't do that, because you really have two. SSH doesn't give you one socket, unfortunately. It gives you standard input and standard output, and they are separate. So this worker function needs to read from standard input and write to standard output. The good news is that both AnyEvent fork RPC and AnyEvent fork pool can work with both of these modules. So whether you use AnyEvent fork to create a local process or AnyEvent fork remote to create a remote process, you can instantly use AnyEvent fork RPC to do RPC requests. Noteworthy is that there's no attempt to make sure that this Perl is somehow compatible with your Perl. That's all your problem. But of course, it doesn't have to be compatible, as long as it runs all the code that you throw at it. So if you run eval, it needs to work with this Perl version, and if you run require, then on the remote machine, this module must be installed, of course. And that's mostly it. And this is what I wanted to tell you. The first thing to repeat it is think twice before I use fork to create process pools, worker pools, or anything to do any amount of work in a child. Because in simple cases it works, but it limits you so much. You need to check, do I have running threads? Do I care about that? He doesn't care about it. For example, that's completely valid. I care about it, but where's my thread? I think that totally sucks. And the same is true for any dangerous module. Sometimes I use AnyEvent fork to temporarily load a module, for example, that I don't want to have in my process at all times, because practical example, LDAP server. LDAP server is great at leaking memory. So when you have a server that runs a lot and it wants to do authentication with LDAP, and you use LDAP server, the LDAP module, the Perl LDAP module, then be prepared to have 1 megabyte per hour of growth or something. I don't know if it's still the case. It's a few years ago that I had that, but in practice, every Perl module, every program leaks memory. Probably most of my modules also leak memory. Some slow, some faster, maybe some don't. But one sure way to fight memory leaks is kill your process from time to time. And the only way to do it is start it, use LDAP, kill it, something like it. And the other thing is, I wrote this great Perl fork family of modules. It's 4 modules, and they're all really tiny, and they're all pure Perl, except they have some dependencies. And maybe one of you Two of you will find it useful at some point in your life. I hope that. I guess it's really special. But when you ever need a fork pull, and the other thing is, of course, as with all my modules, this is really low level. So it's not very convenient. Just like AnyEvent fork, wow, it gives you a process. But just that, just a process and some socket. What should I do with it? So it's not as convenient as some of the other, there are some worker pool modules on CPAN. The problem is they're all broken because they all fork. This is the only way to do it right. I mean, you can fork, but you really need to control the parent process very closely. You can't really use AnyEvent unless you risk all sorts of deep shit. I'm looking at you, yeah. I'm also looking at you most of the time, but that's just accidental. If you ever think you need something like that, think of that it exists.
Yeah, thank you.
Anyways, I hope that, as I said, I expected that like every hour one of you stands up and says, wow, this is deep shit, I wrote it, use it, it's great, wow, whatever. That would be cool, huh?
Yeah.
No, I don't want. I didn't prepare this at all.
How is it different from fork?
Well, nobody knows really. The thing is that vfork could be fork. On many operating systems, vfork simply calls fork. So vfork is a fork with potential limitations. So in Linux 2.2, I think also 2.4, when you call vfork, you get fork. There's no difference because it really is the same thing. But in 2.6, vfork is a bit different. What it does it blocks your parent process, doesn't make a copy, but simply runs your child process as is. So when you modify memory in your child process, you will modify it in the parent process. And this is really damn dangerous. So don't do it. And this is why vfork has this bad reputation, because what can you do legally after calling vfork? Legally, you can do exec. You cannot call any of your own functions. It's not legal to call another function. The only function you legally call in POSIX is exec, one of the exec functions. You cannot call dub2, you cannot call close, legally. In practice that makes vfork completely, or almost completely useless. But in practice, vfork is either fork, in which case you can do all these things because it's safe, or vfork is one of the existing vfork implementations which allow you to use syscalls. So what's a syscall? I don't know what a syscall is. I mean, when I say syscall, everybody knows what a syscall is. But if you try to define it, it's really hard. So functions like dub2, functions like dub, close, probably open, functions which do not actually call complicated stuff in your libc, these are in practice safe to call. So the normal use for vfork is you call vfork. Then if you're a shell, for example, if you're a bash, then you redirect to the input-output, maybe set some particular handlers, something like that, and then you exec. But what is actually legal after vfork? Nothing really, except calling exec. But in practice, you can call anything that doesn't really modify memory. Malloc modifies memory, assigning variables, calling functions might change memory, but calling dup or open normally doesn't change memory.
The second question is, why did you put everything under AnyEvent namespace? Does it use AnyEvent underneath?
Yeah. AnyEvent fork itself uses AnyEvent in the parent process, and AnyEvent fork RPC uses it in the asynchronous backend, but of course also in the parent process. And the way it's implemented is actually really primitive. The biggest problem was, okay, I want to start a new Perl interpreter. So what fucking path is that? That's actually very complicated, and there probably isn't a perfect solution for that. So the module tries to guess a few tries to guess where Perl is located in various ways. And what it then does is, the trick to make it fast is that AnyEvent fork never asks the child process for something. For example, you don't know which PID the process has, because to know that, the process would have to tell you, but it doesn't actually ask it. So all that AnyEvent fork ever does is talk to the process. Or in other words, when you do AnyEvent fork, require run and so on, then when all this is finished, most probably your process doesn't even exist yet, because this creation of the process and loading the module and stuff is completely asynchronous, and AnyEvent fork does not wait at any time. And this is why it can just create processes like really quickly, like mad, because it's really just writing to a socket and never reading from it, never waiting. That's the way to be fast. Never wait. Is that a question?
No, I don't know.